Remember, we've got this hierarchy of biomes, ecosystems, communities, populations, and individual species. And they all kind of fit inside of each other. There's two major processes that happen in an ecosystem. And the week before break, we went through nutrient cycling. Nutrient cycling is the idea of conservation of matter. So matter can change forms as it moves through the cycles. But the second process is that energy must flow through a system. In physics, we define energy as able to do work. And actually, most of the energy in our ecosystems comes originally from the sun. And it gets stored in organic compounds. That process is called photosynthesis. That process of photosynthesis is what we call endothermic. You might have studied that in chemistry, I hope so. Endothermic means that it takes a lot of energy to start the reaction, and some of that energy gets stored or absorbed into the products. Now, respiration is the opposite. It's called an exothermic reaction. And what that means is we use that stored energy for kinetic energy. We eat sugars, carbohydrates. That gives us the energy for respiration. And we give off heat, sweat. Those are all releases of energy from that reaction of respiration. Photosynthesis converts and absorbs. Endothermic. Respiration uses and releases. Exothermic. We can explain this whole idea that we can take solar energy and turn it into chemical using what are called in physics the laws of thermodynamics. Thermo means heat, dynamic means changing. And this is just like the law of conservation of matter. Matter is not created or destroyed, it just cycles through, changes forms. Well, heat or energy does the same thing. In the old days, before we had propulsion and things like that, the roller coaster had to be designed with the tallest hill first. And it had to have enough gravitational potential energy to carry the roller coaster car all the way through the rest of the ride. And as you're going down the hill, your potential energy decreases, but your kinetic energy, your energy from movement, hits a peak right at the bottom of that hill. Same thing is true with a pendulum. We used to do the experiment here at school where you hang a bowling ball from the ceiling. You pull it back, and you let go, and the ball goes from potential to kinetic. It swings through that arc. So energy can change forms. That's the first law of thermodynamics. We can go from solar to chemical. We can go from chemical, our food, to kinetic. Our muscles can move and give us motion. But when we do that, it's not a perfect transfer, is it? There's some energy loss right here. Respiration uses energy. So what we're really talking about here is efficiency. And you can calculate it with output divided by input. How much did you get divided by how much you put in? Now, if we're talking money and you're earning interest on a savings account, that's a good deal. You can get more back than you started with. But if we're talking energy, you will never get more back than what you started. There will always be some lost. You can see at the bottom of the diagram, some of the energy you put in is given off, usually as heat. Second law of thermodynamics, the law of efficiency, it says the transformation can never be 100%. There is always going to be something lost in the conversion. Primary productivity refers to autotrophs. Autotrophs do photosynthesis. They make their own energy from sunlight. And so we'll start with this tomorrow. We'll look at this equation. We'll do some math. I'll give you some examples that make sense. The whole idea is that we are converting energy and it's never 100% efficient.